This is 3.05 Conservation of Mass Lab, and this is just the data collection. I've had emails from several students saying that they did not have access to the appropriate equipment, so I have gone to teachers and borrowed the necessary equipment. Except you'll notice that my beakers are simply cut-off water bottles because a beaker is just a cup. They can have graduations on them, but beakers are not generally used to measure exact amounts. In order to do that, you'd use a graduated cylinder, and my camera quality is pretty low, but there is as close to exactly 50 milliliters of water in this graduated cylinder as I can get. And I'm going to look at the instructions. There's going to be two videos. This is the part one for 3.05 Conservation of Mass. And it says that we will need seltzer tablets, 100 milliliter graduated cylinder, that's this thing, two beakers, that's our cut-off water bottles. We could use coffee cups, we could use a bowl for that matter, it wouldn't matter. Electronic balance, this is actually a scale, but we can call it a balance. Gallon size resealable plastic bag, I've got that over here next to me. That will be in the second video because I have to do all this in one take. And a snack size resealable plastic bag, which I've actually recycled something I carried my eggs to school in. Let's see. Note, if you have trouble finding any of these materials, please ask your facilitator or teacher, that's me, for assistance. Well, here's your assistance. Let's see. Okay, part two, Seltzer Trial 1. Follow the procedure below to complete Seltzer Trial 1. Number 1, place a seltzer tablet into a dry beaker. Okay, I'm going to get this out of the way. Okay, this cut-off water bottle is dry, and we want to put our tablets in there dry so it doesn't start its reaction. I'm going to put 2 in there. Oh, let's go for 4. That way, maybe if there's a big difference, it'll be easier to document what you're witnessing. I hope these don't go over the top. Okay, and let's see. Measure out 50 milliliters of water using the graduated cylinder. Okay, that is this right here. Pour the water into the second beaker. Now, the second beaker does not have the tablets in it, but look what's happening to the mass on the scale. Interestingly, if I measured the water correctly, the water itself should be exactly 50 grams because 1 gram of water is 1 milliliter of water. All right, so our total mass of the initial system, initial being the system we're starting with, is, according to this scale, 54 grams. And it says to record that, and you'll put that in your data table. Weigh both beakers and add their total mass to the chart. Okay, so 54 grams. Leave the first beaker with the tablet on the balance. Okay, that's this one over here. Number 5 says, slowly pour the water from the second beaker into the first beaker. That's the one with the seltzer tablet. So I'm going to take the water, I'm going to add it to the ones with the tablets, and I'm going to go slow enough that I don't get a mess. I don't want any of this to come out on this borrowed balance. Well, that's not as exciting as I thought it was going to be. Okay, let's see. Do not let the reaction foam over the edge of the beaker or you'll need to start over. We didn't do that. And I'm going to set this back here. It says, be sure to carefully watch what occurs. So I'm watching and I can see bubbles forming. I'm imagining that the tablets are reducing in size because they're dissolving, but I can't see through the bubble, so we might have to wait a minute. I'm turning the page while we watch the foam. Number 6 on the instruction says, wait for most of the tablet to finish reacting. Measure the total mass of the final system and record it in the chart below. Letter A says the final system includes the beaker with the solution made by the tablet, that's this one, and the empty beaker. So we didn't take anything off of the balance. Okay, and it is still bubbling. It's still bubbling. Okay, I'm going to do something that is not in the instructions, but I promise it won't change the outcome. I just want to see if we could speed up the fizzy part. It's still going. We're going to wait. I didn't realize this was going to be a 5-minute video. Let's see, while it's bubbling, number 7 says, use the information from the data table to calculate the change in mass for the reaction. This is the difference between the mass of the final system, which we're about to get, and the mass of the initial system, which is what you wrote down at the first. Record your calculation in your data chart. Anytime they ask you to calculate a change in something like this, usually there's some subtraction going on. So we're going to take the initial mass, subtract the final mass, and we'll get a change. And number 8 says, based on your data, did this reaction follow the law of conservation of mass? Defend your answer using evidence from the investigation. You know, if I was looking at this and I didn't know what was going on, I might think the law of conservation of mass was not upheld, because look what's happening to the mass. We're at 51 grams now. You might have to back up in the video to see where we started. But you're going to have to explain what happens. All right, I'm going to check and make sure. Okay, here in a minute, I'm going to get the bags together, and I'm going to start another video for part 3, Seltzer Trial 2, with the bags. Okay, so that's the next video. All right, go ahead and get your data, and you can pause as long as you need. 6 minutes and 30 seconds.